We are doing non-homogeneous differential equations part 2. So just to recall from the previous video, a non-homogeneous differential equation is a differential equation that is equal to gx. So we're going to solve the general solution of the non-homogeneous differential equation, and remember it will be in the form of y equals y complementary plus y particular. So in the first step we will solve y complementary, and then in the second step we will solve y particular. Now remember, to solve y particular we are using the methods of undetermined coefficients, and we must thus look at the form of gx to give us an indication of the particular solution yb. So what we're going to do is we will look at the table, and on the left hand side we have the specific form of gx. On the right hand side we have the corresponding form of y particular. So just to recap, if our gx is, for instance, a quadratic polynomial, the form of yp, it will also be a quadratic polynomial. But remember the very important fact: if a function in the assumed particular solution is also a solution of this associated complementary function, then yp must be multiplied by x to the n. What is n? It's the smallest possible power that will eliminate duplication. But I will explain it again as we do the next example. So this is a typical test and exam type question. So what they will ask us to find the general solution to the non-homogeneous differential equation. So remember what I've just said. When you do the general solution, you will do y complementary plus y particular. So we have to do y complementary always first. So now what we're going to do, I'm going to run through this very quickly since we have done it now a couple of times in detail. So just remember, for the complementary function, you will let the right hand side be equal to 0. As you can recall, we will find the auxiliary equation or characteristic equation. Now, the third derivative is equivalent to m cubed, second derivative m squared, first derivative m, and y is just 1, so that we have our characteristic or auxiliary equation. Now, remember, the possible roots will be plus or minus 1, but I'm just going to do it here quickly. Since when I substitute y equals 1, I get 0. I know m equals 1 is a root, and I continue doing synthetic division to find my other two roots. So from synthetic division, I'm not going to explain the method again. By now you should all be familiar with that. But I will get my factors. Since 1 was a root, m minus 1 is a factor. And now from here, I know that I have m squared minus 2m plus 1 equal to 0. When I factorize that, I get m minus 1 squared. But now, just make 100% sure you understand this, I get m equals 1 3 times. So the multiplicity is 3. Multiplicity is the number of times the root appears. It is 3 times, hence a triple root. So when I have a triple root, I know now m is 1, so I have c1e to the x. For a double root, I would have times by x. For a triple root, I will times by x squared. And there I have my complementary function. So now on to my particular solution. Now, just recall what I've just said. You will look at the form of your gx to give you an indication what the form of your particular solution will be. Now, since my gx is, my first part is x, I know from the table that that's a linear equation, so my assumed particular will be ax plus b. Then I have 4e to the x. From the table, I know that my assumed particular will be a constant times e to the x. So now, if I combine those two, I get ax plus b. Remember now, that is the particular form that can be associated with this linear form. And then I have c e to the x. That is my y particular from this part of gx. So there I have my assumed particular form, and that is all from the table. So I used the linear form and I use e to the mx. So now remember, very important, I have to compare my particular solution to my complementary function to see which of the terms in the assumed particular solution is repeated in my complementary function. This term is not repeated here. My constant not repeated here. What do I see? C e to the x is repeated here. So just remember what I've just said. I must times by x to the power of n, where n is the smallest power that will eliminate duplication. Now let me just explain that again. If I times c e to the x by x, I will get cx e to the x. But what do I see? It is still duplicated in my complementary function. Hence, my next step, I will times by x squared. What do I get? I times my c e to the x by x squared, I get cx squared e to the x. But what do I see? It is still duplicated in my complementary function. So therefore, I times by x cubed to eliminate duplication. What do I get? When I times this term by x cubed, I get cx cubed e to the x. That term stays the same. So as you can see here, I've times by x to the n, where n was the smallest power that will eliminate duplication. I cannot just times by x or x squared, since it does not eliminate duplication. Now, what do I have? Now I have my particular solution. Now, what is very important, what we're going to do now in this video, we will solve our A, B, and C's, so that at the end we can get our general solution. Now, what do we always do in this case? We see from our question, here is our question, that if we substitute our y particular into that equation, on the left-hand side, we will get the right-hand side, since it is a solution to the differential equation. So what are we always going to do? We're going to substitute y particular into y. But now we see that we need y prime particular. We also need y double prime particular, and we need y triple prime b in order to substitute into this equation. So you will always look at what's given, and you see you need which derivatives will be needed to substitute in. So I'm not going to do this in detail because these are all basics, but just to start you onto this, we have our particular solution. Now remember I said you need these derivatives. So I derive this once I get that. I will derive twice. Now remember when I derive twice, by now you should know this, that I will use the product rule over there and I will use the product rule over there. And then I just added like terms. So what I prefer doing here, I prefer taking out the common factor so that I have two brackets now, because now that will make my product rule easier, since this is the second derivative. So now I'm going to derive again. Now just remember from first year, if you have three functions prime, you will still do the product rule. So that's what I've done here. I've done the product rule again so that I can get the third derivative. Now, after this lesson, you can just make sure and verify that you got exactly what I got. There are different methods. For instance, you don't have to take out the common factor as I did here. You can just do the product rule with each term, and then if you derive that, you will get your third derivative. So you can either pause now and just verify that you get that, or you can just check it later. Now what we are going to do, we will substitute our third derivative, second derivative, first derivative, as well as our y into this equation. So in other words, as you can see here, you will do y particular third derivative minus 3, y particular second derivative plus 3, y particular first derivative minus y particular is x minus 4e to the x. So that's what we're going to do. So you can, even in the test, you can remember that this is still your particular solution that you are deriving to be able to substitute. Now what I did in the next step is just the basic maths. So just make sure that you do understand what I'm doing. So I substituted my third derivative. Then I did minus 3 times my second derivative. Then I did plus 3 times my first derivative. And then I just substitute my particular solution and I equate it to x minus 4e to the x. Now what I did, so that's also basic math, so you can verify it by yourself. I did just times everything out on the left hand side. I ended up with this, and then I added like terms. So you can spend time on that and make 100% sure that you understand that. Now what we're going to do, remember now that we need to solve our A, B, and C. Now what do we do in maths always when we have one equation equal to another? We will equate coefficients. So let's just check this. On the left hand side, my constants are plus 3a minus b. On the right hand side, I have no constants. Hence, 3a minus b is 0. Now what we're going to do, we will look at the coefficients of x. So, let's see. I have negative a there, coefficient of x. That's the only thing I have there. And on the right hand side, I have one coefficient of x. Hence, minus a is 1 and a is negative 1. And I have solved my first arbitrary constant. Now, if a is negative 1, what I'm going to do, I'm going to substitute it into equation 1. So if I substitute negative 1 into equation 1, I get b is negative 3. Now, what is the last thing I need to do? I need to find c. Now, what you can see here, you have the coefficient of e to the x is 6c. And what else do I have? On the right-hand side, coefficient of e to the x is negative 4. So I have 6c is negative 4. So hence c is negative 2 over 3. That's when I equate my coefficients of e to the x. So what do you see here? We don't even have to use the other terms since we already have solved a, b, and c. Now what do we see? Remember, we're finding the general solution. So we have y particular is my y particular 1 plus particular 2, which was ax plus b plus cx cubed e to the x. From this form, from that form. But just now I have solved a, b, and c. I substitute a negative 1 in. B was negative 3, substituted back, and c was negative 2 over 3. And there I have my particular solution. But what did the question ask for? The general solution, y complementary plus y particular. Remember, I got my complementary function right in the beginning. Now I got my particular, and there I have my final answer. So I only have the arbitrary constants C1, C2, and C3 left. If they ask you to solve those in a test, you will use the following conditions. So remember, it was a third order differential equation. So they will give you your 3 initial value conditions. So they will, for instance, give you these, and they will say, now solve C1, C2, and C3. So if you have forgotten this, you can watch the videos on homogeneous differential equations where I did mention that. So just remember, if it's a second order differential equation, so if you get a second order differential equations, no matter what you get, so whatever we have here, and you have solved now your general solution, you found your complementary in particular, and you did solve your arbitrary constants from your particular. Whenever you have to solve now your C1 or C2 for the complementary function, you will always substitute the initial conditions in. So for a second order differential equation, you will have 2 arbitrary constants that you're going to solve. So they will give you 2 conditions, for instance. They will say y0 is 1 and y prime at 0 is negative 3. So, and that is to solve then your C1 and C2. So just recap, if it is a third order differential equations, there will be 3 conditions and you need to solve your arbitrary constant. If it's a second order differential equations, there will be 2 conditions and you will solve your 2 arbitrary constants. And that is the end of non-homogeneous differential equations part 2.